All right, welcome everyone. This is the final seminar of the Sports Analytics Lab section in Statistics and Sports seminar series. So today, to finish things up, we are pleased to have Luke Benz and Mike Lopez. Luke Benz is a data scientist at Medidata Solutions, where he works to solve statistical problems in order to run smarter clinical trials. He holds a degree in applied math from Yale University, where he was president of the Yale Undergraduate Sports Analytics Group. And he'll be starting his PhD in biostatistics at Harvard, at the Harvard School of Public Health in this fall. And Mike Lopez is the director of football data and analytics at the National Football League and is a lecturer of statistics and research associate at Skidmore College. At the NFL, his work centers on how to use data to enhance and better understand the game of football. He has a PhD in biostatistics from Brown, a master's in statistics from UMass Amherst, and played football as an undergraduate math major at Bates College. So welcome to you both. I should mention before you get started, if anybody has any, if you have any substantive questions, please leave it for the end. We'll have time for question and answer. If you have any clarifying questions, please feel free to raise your virtual hand, or you can ask something in the chat, and then I can go ahead and interrupt.
Thanks so much for that introduction. Can everybody see this all right? Perfect. All right. So today we'll be talking about what happened in soccer's home advantage during the COVID-19 pandemic. So home advantage is a well-documented phenomenon across sports. Loosely speaking, that term refers to the fact that regardless of the sport, the home team often wins more than the away team. And in fact, it's not necessarily just in binary win-loss outcomes, but in other aspects of the game. So an example in soccer, home teams often receive fewer yellow and red cards, fewer fouls than their away counterparts. And we see this effect, over many, many games, many, many seasons. And it's kind of been well documented for a long time. But it's hard to exactly pin down some reasons why this happens in any kind of causal way. And so the fact that the COVID pandemic disrupted so much of our day-to-day life in the last year plus provided a unique opportunity for a natural experiment in that pretty much all sporting events, at least for the first several months after the pandemic hit, were played without any fans in attendance. So a natural question is, why do we care about soccer and not other sports? I think other sports are interesting as well, but we specifically have chosen to look at soccer because it was the first sport to return to play after the pandemic, or I guess I don't want to say after the pandemic, but after its pause of play from the pandemic. And furthermore, it had its season interrupted halfway through with a return to that same season in a non-bubble format. So if you think about the major North American sports, the pandemic sort of interrupted normal sports seasons in baseball and football before those seasons had started. So basically the entire season was played either without fans or with very few fans. And for sports like the NBA or NHL, which were interrupted during the course of the season, when they resumed play, it was a bubbled environment where there wasn't really the notion of a home team and an away team and teams traveling to play each other. So that's sort of what makes soccer a little bit different than some of these other sports. So today we'll specifically be trying to get to the bottom of what happened to the home advantage change in soccer, specifically on the outcomes of goals and yellow cards. And I'll hand it over to Mike for a little bit, and then He'll talk about some of the background, and then I'll take it back for the results.
Great. Thanks, Luke. And again, Mark, thanks for the invitation and the opportunity to talk about some of this stuff. So as we sort of started this project, part of the motivation for doing it wasn't just to sort of uncover some of the goals that Luke mentioned with respect to the potential decline in the home advantage. Part of it was driven because we continued to read other folks who were attempting to answer the same question, and maybe some of their approaches didn't necessarily mesh with maybe what Luke and I felt was appropriate. Specifically, a couple assumptions guiding some of this stuff. And as we think about leagues and how they operate, there's a lot of fundamental differences with respect to travel, rest, team talent, the distribution of offensive and defensive strengths. And it maybe doesn't necessarily lend itself to just sort of assuming that all leagues and all teams in those leagues follow the same process. And a couple assumptions that were fairly common, and I'll show you a table in a couple slides, are that first, the home advantage is there's one sort of term that represents home advantage across all of soccer. And that's one sort of general guiding principle, is that there is a constant benefit to being the home team that is the same if you are in Serie A and the same if you're in the Premier League. It's also the same if you're in German 2 Bundesliga. And depending on which number of leagues you're looking at, that may or may not be valid. Additionally, the typical approach that was employed was linear regression. And there are a couple different forms of that, which I'll go through. But it maybe didn't necessarily strike us as the most appropriate outcome model framework for soccer outcomes. And so as we were doing some reading, we compiled this table. This summarizes what at the time was exhaustive list of the 13 papers that had looked at soccer outcomes post-COVID. And I'll note as an additional commentary, this is a fairly popular phenomenon for researchers to look at these natural experiments, in part because first, a lot of people like modeling soccer in general. And second, trying to untease the mechanisms behind the home advantage, and Luke hinted at this earlier, this has been going on for ages. And for folks who have read Scorecasting, the authors of that book make several conjectures and suggestions as to what are some of the driving mechanisms behind the home advantage. And they have some really creative natural experiments that they used in that book, or that they summarized. And it's really interesting to sort of think about, like, what are the roles that the referee plays in home advantage? And I think a lot of the sort of motivation behind this is to really try to parse out, like, how much is that crowd impacting the home advantage? And if you take away the crowd, now you can maybe tease out the fact that the crowd could be impacting officials. So just on this table, the row variable is each paper. The columns reflect the authors, the number of leagues, the method that they used, and the overall finding. And a couple of things that I'll point out. One is the main method is linear regression. And just from a sort of like, what is the outcome? Well, one could be like who wins. And so that would be sort of like a linear probability model. A second would be like goal differential. And so that would just be linear regression with goal differential as an outcome, and then some independent variables as sort of predictors. And then the next thing I'll point out is not only do we have the number of leagues that were looked at, but I also sort of added in parentheses whether or not the leagues were treated together or separately. And the majority of folks that have attempted this approach have treated each of the leagues as together. And when I say together, there might be a certain term for each team in a model, but there is just one term for the home advantage that reflects the home advantage that sort of is ubiquitous across all the leagues. And so as we'll show, that seems to be an assumption that's probably not justifiable. And then the far column on the right is their overall conclusion. And I do think that the initial sort of, I guess the main findings that most folks were developing is that there was a significant drop in the home advantage. And it definitely led to some headlines in the online web world about, the referees were impacted by the crowd, and now that there's no crowd, they're no longer impacted and the home advantage is gone. And, I think our finding, we're the bottom row, just to sort of separate, how our approach stood out and our results. We're certainly more on the mixed side, where there's probably some more minutia that needs to be discussed. In terms of the data, Luke scraped footballreference.com, and this goes back for dating from the 15-16 to 19-20 seasons. We also have the exact date of the restart. German 1 and German 2 Bundesligas were the first two leagues to restart. And so this table is separated by league and then organized by restart date. We also provide the number of games pre-COVID and post-COVID, and roughly the number of team seasons that each correspond to. There's a surprising amount of data on footballreference.com. We've primarily focused on goal outcomes and yellow card outcomes. However, there's a lot more other variables that could be looked at. And I would encourage folks who find this interesting and do want to look at the home advantage or other things in soccer. It's the reference family of sites is pretty awesome in terms of scraping and being able to use. And thank you to any of the folks that have done that, just because it made our lives much easier. So in terms of the initial way we thought about modeling, it definitely is not our approach. This was, I believe, first introduced in a paper in 2003 by Carlos in JRSSC. Journal of Royal Society version D or C or D, one of the JRSSs. And I'll go through this model, and this is just sort of a general model for soccer outcomes. Luke will expand in a little bit how we applied it to post-COVID. So first, our interest here is in, so bivariate, we have two outcomes. Our two outcomes are going to be, just as an example, goals for the home team and goals for the away team. So that would be YH sub I and YA sub I. Assuming that it's distributed bivariate Poisson, there are three parameters in this bivariate Poisson distribution: lambda, 1i, 2i, and 3i. And I'll go through each of those, but those roughly correspond to the home and away goal scoring intensities, as well as the correlation in the goal outcomes. So for example, lambda 1i is a function of some overall goal scoring intensity that corresponds to K and S. I should note that K and S in this case are league K and season S. T sub K would be the home advantage. And so if we look at lambda 1i as the goal scoring intensity for the home team, lambda 2i as for the away team, T sub K corresponds to a league K specific benefit of being the home team. And these are on the log scale, as it's a Poisson model. The terms on the right in purple reflect sort of the way that we would assume the sort of team specific factors that we would think would link to goal outcomes. So first, alpha HKS, that would be the goal scoring intensity for the home team. And then delta AKS would be the defending strength for the away team. So as we think about how the home team scores goals, that's going to be primarily a factor of how good that home team is on offense, as well as how good the away team is on defense. And then if we're looking at the away team, which would be lambda 2i, that would be a function of how good the away team is on offense. So that would be alpha sub A. KS, and then how good the home team is on defense. And just sort of the way the expectations work out is lambda 1i plus lambda 3i is the goal expectation for the home team. Lambda 2i plus lambda 3i is the goal expectation for the away team. And the covariance in goal outcomes is lambda 3i. Again, this is each corresponding to league K. And so in this case, we're assuming that the T sub K, we can represent one for each of the leagues. And so we would apply this separately to each league in order to estimate that. So that's sort of the common approach for soccer. Most of the typical approaches that we were reading assessing the post-COVID changes in home advantage relied on a linear model. And one example that was fairly popular was to model goal differential, which would be just the change in goals, or sorry, the difference in goals between the home and away team in game I. And that's a function of terms for the home team and away team. And this is actually a little bit important to parse out in that each of the two teams is going to have a separate term for when they're at home and when they're on the road. So in other words, the assumption here is that the home team, when it's at home, has a team strength. And then when that same home team goes on the road, it has a different team strength, and that those would not necessarily be related to one another. In this case, the alpha corresponds to the benefit of being the home team on a goal differential scale. And then I'm not sure it's justifiable, but the errors are assumed to be normally distributed. So our first thought was, let's just try a bunch of different soccer seasons and see how these two models do when we actually know the home advantage. And so we simulated a bunch of seasons using bivariate Poisson and just sort of saying like, okay, let's generate seasons that look like seasons. Let's assume that we know the home advantage, and let's see how each of these models do. We also sort of aligned it so that the home advantage could go as low as 0, no home advantage, but that it would reach sort of no higher than what we would observe in reality. And we drew that from a uniform distribution. We had attacking and defensive team strengths that roughly represent what we would observe in real data. So in other words, if we were to go look at the EPL or Serie A to sort of correspond to the relative amount of standard deviation we would assume or we would see in those leagues. We generated goal intensities, drew scores from a bivariate Poisson distribution. We assumed, at least for this modeling, that there was no correlation in the goal outcomes. In this case, the bivariate Poisson is really just a product of two independent Poisson distributions if there's no correlation there. Why that sort of last assumption? Most of folks who have looked at soccer data over the last 15 or so years have concluded that there, even though there is a correlation in a bunch of outcomes, including yellow cards, at least with goals, they seem to be roughly independent. And then what we did is we fit the bivariate Poisson model and the linear regression model. The linear regression model, again, we're not assuming is going to be great, but we're more doing it just to sort of compare the approaches that other folks were attacking this problem with. So this graph just shows the bias in estimating the home advantage. And again, if we're simulating, we do know the truth, and each dot in this case corresponds to one of the 200 simulations. And at least in terms of a mean absolute bias, there's a slight positive bias for linear regression if you look at the median of the box plot. But realistically, the mean bias isn't really what's of interest. It's the mean absolute bias, which is pretty high with linear regression. And there's just a lot of noise to try and estimate soccer outcomes this way. And so, for example, you could be trying to estimate a single season's worth of soccer games and get a goal differential. This is on the goal differential scale, I should also note, that is, up to a goal higher or goal lower. And that wouldn't be all that surprising. Whereas when you look at our bivariate Poisson model, and this is extracted to a goal differential scale, your typical mean absolute bias is somewhere around 0.07. And so again, obviously you're not going to be perfect in a single season of soccer games, but relatively speaking, I think it makes a lot more sense to use bivariate Poisson. I'll note that these simulations are a little bit overconfident in the sense that if we're simulating using the bivariate Poisson distribution, we would hope that the bivariate Poisson distribution would do pretty well. One of our feedback from our initial submission was that we should vary that. Those results aren't ready for presentation today, but we did actually expand our sort of suite of models and our suite of data generating processes, so to say. And specifically, we're also going to include some comparisons to paired comparison models like Bradley-Terry, and try to figure out like how would other models do, and also what would it look like if, instead of assuming that your goal outcomes were bivariate Poisson, what if there were other distributions that you sort of assumed were the underlying way that goals were scored in soccer?
All right, I'll take back presentation. And so now that we've sort of established that bivariate Poisson model is at least better than for estimating home advantage compared to kind of the the common linear regression approach in a lot of the initial papers out on the topic. I'll briefly talk about how we sort of extend this model to think about the change in home advantage in the COVID setting. So we basically will take the same bivariate Poisson model that Mike presented just a few slides ago, and we'll start by modifying it so that it has two separate home advantage terms. Basically, it's a pre-COVID and a post-COVID home advantage term, or in other words, like a before the pause and after the pause. When we fit this model, as Mike had alluded to, we assume for goal outcomes that this lambda 3 or the correlation is 0. That's, as he alluded to, sort of based on both empirical and some theoretical consideration. The Carlos paper about 20 years ago analyzed data from like the early 1990s Italian soccer. And back then they had a point system that was 2 points for a win, 1 for a draw, and 0 points for a loss. Nowadays, pretty much every soccer league in the world uses like 3 points for a win, 1 point for a draw, 0 points for a loss. And the effect of this is that the frequency which you see ties has dropped pretty dramatically. I think in early 90s Italian soccer, it was like 36 or 38%. Most of the 17 leagues that we analyzed in this project are in the low to mid 20s. So ties are about 1/3 less frequent than they were 20 years ago, 25 years ago. And as a result, probably this correlation term is not really needed anymore for goals. That's not going to be the case, as we'll see with yellow cards. So how do we actually fit this model? So we fit a Bayesian version of this model in STAN. And a major benefit of taking a Bayesian framework is that for each league, we'll be able to determine a posterior probability that the home advantage for that outcome declined. Over to the right, you see some of the priors that we use. Basically, they're very weakly informative. It doesn't really limit the range of realistic outcomes. And a little bit about the model fitting specifics. These are fit with 3 chains of 7,000 iterations each, and we can throw away the first 2,000. So that leaves us for each parameter with 15,000 samples at the end. And we assess convergence using the R-hat statistic. So here are some results. We see posterior distributions for the pre and post-COVID home advantage terms for each league. The pre-COVID distributions are in blue, and the post-COVID are in red. First, I'd like to point out that the pre-COVID posterior distributions are clearly different from one another. I mean, if you look at a league like the Greek Super League compared to the Austrian Bundesliga, where we see a much lower home advantage, I believe the Greek Super League is about 2.5 times as large a home advantage as in Austria. So this gets back to that assumption that a lot of the initial papers made in that home advantage was the same everywhere in Europe or whatever other leagues they were analyzing, even before COVID. So a lot of them assumed like not only were they the same before, but that the pandemic and the effect of not having fans in the stands would impact all leagues the exact same. And we see that.
Luke, I'm sorry to interrupt. The x-axis is on the log scale, right? It's on
the log scale. Yeah.
Okay.
Sorry, I forgot to point that out. Yeah, this is not on the goal differential scale. For a bivariate Poisson model, you have to both like exponentiate it and kind of subtract that mu term. It's relative to a league average, but for the purposes of still comparing these leagues relatively to one another, it's reasonable to say that they're not all the same. But yeah, good call out that unlike our simulations, these are not on the goal differential scale. So yeah, as I was saying, even before COVID, we see that not all of these leagues were the same. And then when we switch our attention to kind of these post-COVID restart distributions, we see that all the leagues are impacted in different ways. So a couple of the leagues took some pretty dramatic declines, like the Austrian Bundesliga, German Bundesliga. We see, the median of these distributions is below 0. It's almost suggesting that home advantage disappeared altogether, or not that we're seriously suggesting this, but in a small sample of games in Austria, it's almost like there was an away team advantage. But if you look at other leagues, you see a smaller decline, or in others, even a slight increase. Like the Swiss Super League had a pretty big increase in its home advantage. Others, very small change. And if you can imagine sort of asking yourself the question, like, what's the probability that a draw from this blue distribution is larger from a draw than the red distribution? That's how you can derive these posterior probabilities of home advantage decline. So what we see is that there are several where there are a greater than 50% chance of decline, but it's really a pretty wide spectrum. We have a couple at the top. I believe there are 5 or 6 leagues where there's like a greater than, or there's I think 5 leagues where we have a greater than 90% posterior probability of decline, but a lot of leagues were lesser, and even a few, I think 5 or 6, have less than a 50% probability of decline, meaning basically the posterior mean of the post-restart home advantage was actually larger than it was before the pandemic. Now, if we move on to our other outcome of interest, yellow cards, we're basically using the same modeling framework. It again has 2 home advantage terms. I'll point out a few small differences between this model and our goals model. Unlike our goals model, where we had sort of 2 team terms, an attacking team strength and a defensive team strength, we sort of make a simplifying swap here, and we just have 1 team, basically team effect in this model. The reason for that is there's not as much of a distinction between, so if you sort of think about what would like an attacking and a defensive team strength translate to in the yellow cards model, it might be something like a propensity for drawing or giving yellow cards. And the sort of range of what those team effects would look like is a lot less. In other words, it seems like the season to season change between how many cards above league average a team is able to draw or concede is not as strong as giving away or scoring goals. I'll also point out that for this model, we do allow lambda 3 to be greater than 0. The correlation between home and away yellow cards is a bit stronger than goals. So here are the results for our yellow card model. I'll point out that in this graph, kind of the smaller or more negative the number, the bigger the home advantage, because home advantage means away team scores more goals than an opponent, but it means that it gets fewer yellow cards than an opponent. So you sort of have to flip how you're reading this graph. Again, we see sort of a range of distributions before COVID, and that not all the leagues are the same. But interestingly, we'll see that sort of yellow cards are more directionally impacted in the same way than goals were. In other words, a lot of these red distributions post-COVID restart moved to the right, indicating a decline in home advantage and yellow cards. And looking at these posterior probabilities, it's actually the case that 15 out of our 17 leagues had a greater than 50% decline in home advantage, and again, about 5 or 6 had a very likely decline in home advantage. So if we start getting to think about answering the question, well, did home advantage decline? Did it not? It's tempting to say, yes, it did, which is what a lot of the original papers did, but it gets a little more nuanced than that, as Mike alluded to. And really, I think the right way to look at this is you have to split it out by league. It depends what you're analyzing. So we've selected a few different leagues here. We plot on the x-axis sort of yellow card home advantage, on the y-axis goal home advantage, and then we draw an arrow from a point, what was it before COVID to what was it after COVID. If you look at certain leagues like the Austrian Bundesliga, the German Bundesliga, recall the German Bundesliga was the first soccer league to return and was a subject of a lot of those early papers. So it's natural why they would say something like, oh yeah, there was a huge decline in home advantage. Home advantage is gone altogether. I mean, if you look where this point ends up, it's right about at the origin, both in goals. There doesn't appear to have been any advantage for the home team on either outcome. In fact, maybe even a slight disadvantage. Sort of same thing in Austria. But if you look at other leagues, it tells a very different story. I mean, even in the same country, Germany, you see the second division had a big drop in the home advantage on yellow cards, but essentially no change, even a very slight increase in home advantage and goals outcomes. And you see that in other leagues like Portugal. And then even in other leagues of the same caliber as the German Bundesliga, this quote unquote big five leagues, like the English Premier League or Italy, the top league in Italy, you see an increase in home advantage on both outcomes, ever so slightly. So all this to say, the picture is a bit murkier than a lot of original papers might make it seem. And overall, we have about 11 leagues out of our 17 fall into this red category of a drop in both outcomes. 4 leagues in this purple category where yellow cards declined and there was a slight increase in goals home advantage. And then these 2 leagues are the only ones that fall into this blue category of an increase in both home advantage outcomes. And interestingly, none of our 17 leagues fell into sort of this 4th category where home advantage declined in goals and increased in yellow cards. So yeah, like I had mentioned, the discussion gets a little murky. In fact, as we see, it's not always the case that these changes in yellow card home advantage are necessarily linked or translate to a similar drop in goal home advantage. So while it might be tempting to say that the lack of fans implies less referee bias, we see that it might also be a difference in player behavior. And you know, I think we want to be really careful about drawing any causal statements. What we're observing is a changed home advantage, not only from a lack of fans, but a number of factors, including a lack of fans, but also massive changes to the training abilities and the day-to-day lives of these elite athletes who, like any of us, have never experienced such a disruption to our normal lives. I think there's a really interesting quote from Messi himself when he was asked about how it felt to play without fans. And he goes on to say that it's horrible to play without fans. It feels very much like training, and it's sort of hard to really kind of gain that game mentality, work into the game. And so this sort of gets to what we were talking about, that there's probably some impact that fans had on referee bias, but player behavior, player energy might be lower without the home crowd to energize them. So to summarize, we feel that the bivariate Poisson soccer model is better suited for home advantage outcomes, or home advantage estimates on a range of soccer outcomes than the more common linear regression model that's been used. We feel that home advantage is definitely not the same in all the countries and leagues that are being analyzed, and it doesn't make a lot of sense to combine them and try to make one sort of uniform statement like home advantage declines by 50% in all of Europe, but rather splitting it out by league and makes the picture a lot more contextualized. And finally, we do conclude that while home advantage declines in many leagues, it didn't disappear altogether in most, and it didn't decline in every league. And what we're observing is, in large part, due to lack of fans, but that's only one of many factors influencing this. So we're happy to take any questions. Here's some links if you want to see the full paper. All our code and data is available online. Like Mike said, football reference and the sports reference family in general are a really good source of data. And for a lot of these leagues, we've collected tons of other features just besides the goals and the yellow cards that we presented. So if you want to poke around more, all the data's there. The slides will be posted online. And I guess the other thing I'll point out is, as Mike mentioned, we have some updated simulation results coming out, hopefully in the near future. Those will probably go up to the archive soon, and keep your eyes out on Twitter if you're interested in seeing those. We'll post some links. Yeah, thanks, and we're happy to take any questions if people have them.
Let's thank the speakers. All right, please raise your hand if you have any questions. I can call on you. Emilio, you have your hand up?
Just clapping. Sorry.
Oh. I can start off with a question. So I think one of the things that struck me, that's nice, is that you do make sure that you split up home advantage. One of the things that I was thinking about as you were presenting the results showing the pre-COVID and post-COVID home field advantage is whether there might even be like some differences within a team of home field advantage even by season. I mean, they might be slight. I mean, these aren't going to be enormous differences. But I guess what I was wondering is, the fact that you have all this concentration in the posterior distributions for pre-COVID is, partly, because you're basically putting together all the seasons and assuming one common home field advantage for a team across seasons, if I understood correctly. And I guess I was wondering if there's, the way to tease out whether, for example, like there might be a team where, just from the composition of the team, maybe the home field advantage is like slowly declining over time. And so that the COVID result is not that far out of line with the trajectory. And so I guess it's more of a question of wondering whether it's worth considering, a version of this model that assumes that the home field advantage may vary by season even pre-COVID.
Luke, if you want to go to the model.
With the COVID term?
Yeah, either way. Right. I think the question could be, should we have where on the left side of the purple pink rectangle, T sub, right now we just have T sub K. I guess the two questions, could it be T sub K I for, should it be T sub K for H sub I, the home team? Or should it be T sub K, H sub I, S for the home team in season S? I think that's a fair question, like whether or not, especially even just T sub KS, right? Should the pre-COVID home advantage, does that vary by season within a league? I think that's a fair question that we didn't look a lot into. I will note there is a fairly large body of literature that does suggest the home advantage is slowly declining over time. Whether that's enough to sort of, if you think about the posterior distributions, like lead itself so that, the post-COVID home advantage is sort of similar to like just the 2021, when you get rid of 15, 16, 17, 18, 19. I doubt that's the case, but I do think that's an interesting model that we could certainly add.
Yeah, I was going to say that an easy way to check it is without fitting a new model. You could even just restrict yourself to, say, 2019 data, and then post it. Just forget about all the previous data, just so you have much more recent pre-COVID data, and then just see what the changes look like.
Yeah. I actually did a little bit of that. It doesn't change drastically. Basically, you get a little bit wider distribution for those blue distributions before COVID. And I think it's a very good question. If we were going back farther than 4 or 5 years that we use, I think certainly would not be a great assumption to assume sort of like one fifth pre-COVID home advantage. Empirically, if you kind of like just plot the average home minus away goals for each league, for each season, and you look in each league, what happens over those 5 seasons, it doesn't really change that much year to year. If we were looking like, 10, 20 years ago, especially if you go back and use some of this earlier data where they have different incentives for a win versus a draw, I think, you should definitely do that. I think another thing that is worth pointing out is some papers, might want to treat 2020, 21, or I guess 2019-20 season as 2 separate seasons. So they basically have a 2019-20 season up through March, and then kind of like the May, June, July season. And what's difficult about that is in some of these leagues, you have 7, 8, 10 games to estimate a lot of these same parameters like team strength. We think that it's not the best assumption to assume the team strengths are the same before and after COVID, given like we mentioned, the difference in access to training, sort of different incentives for teams when they return from their layoff. If a team is not been training for several weeks or months, and they're sort of locked in the middle of the league where they can't qualify for the Champions League by being at the top, and they're not going to be relegated. It's reasonable to think that maybe they're kind of not necessarily trying as hard than they would have if they had bigger incentives at the top or the bottom of the league. So that's another simplifying assumption that we make, kind of based on small sample sizes in that last half season or third of the season. But good question.
Makes sense. Emilio?
Thanks. So the first question relates back to this home field advantage for goals scored. Did you take into consideration things like stadium capacity and attendance of the games? So some of the leagues, they might not be as popular as other leagues, and so maybe the fan density at those games are not as great, and that might have an impact on the referees and the goals scored. And this also relates back to the yellow card one. Is there any correlation between leagues where you saw things reverting or going back to more evenness for goals scored, but also maybe not so much for yellow cards?
Yeah, that's a good question. Some of those features that you mentioned, like stadium capacity, attendance, were some features that other papers had looked at, and to be honest, we didn't really use them. I don't think that it makes a huge difference. I mean, if you look at some of the earlier papers that do use them, a lot of them find them to be not so significant. We sort of could have done that, but ultimately elected not to. And then I think your other question was about, or would you mind stating your other question again?
Yeah, sure. Is there a correlation or maybe even an inverse relationship between goals scored and yellow cards pre and post pandemic for different leagues?
Yeah, that's a really good question. We did think about that a little bit, and there was not a huge trend, but something that is really interesting is the English Premier League. We see basically no change, if anything, a slight increase in home advantage and both outcomes. And the reason why that's really interesting is the English Premier League has a reputation for being a more physical league. In other words, letting a lot more contact continue without, fouls, or sort of what it takes to get a yellow card maybe is a bit more significant than a lot of other leagues. And that's reflected in a much lower, cards per game than a lot of kind of the other big leagues, German Bundesliga kind of being on the other end of that. And then the other reason English Premier League is really interesting is it was one of the later leagues to restart. Germany restarted in May, and I think the Premier League came back like mid to late June. So by that point, some of these clubs might have had better access to training and sort of more time to ease into some of the games than these leagues that came back right away. So I don't know, like we don't have a plot of it, but there's not like a super strong correlation between either some of these temporal aspects of like when did the league come back, or sort of these other characteristics like the average cards per game or goals per game. But it definitely does get you thinking, like, why England, why is this Italian Serie A league different than, what we're seeing in most other leagues? And yeah, your question alludes to maybe some hypotheses we have, but nothing too definitive.
Great, thank you.
There's a question in the chat from Jean-Louis Foyer, if I pronounced it correctly, which I think is relating to what you were talking about in answering your question, but slightly different angle, which is, how do you explain the change in the correlation between home and away goals from normal to COVID period?
How do we?
I guess the way I'm understanding it is like what aspect about how the games are being played that would explain
Why goals are different?
Yeah, or why the correlation is particularly different.
Mm-hmm. Yeah, that's a good question. We haven't thought too much about that. You know, I think like natural next steps would, we have expected goals or XG available for a lot of these leagues. And, you know, we haven't really studied this closely, but it would be very interesting to see, like, are XG similar before and after this? And, you know, players just like not shooting as well, given equal opportunity chances, or are they just worse at creating as good chances as before? And if that's the case, that could be driving some of the correlation difference that you see. But no, I think these are all good questions, and you know, prompt good next steps that that we have some data for, but just haven't had the time to look into yet.
Does anybody else have any questions? See, Walter, let me ask Walter, since I think he beat you, Tommy, but you're next. Walter Hill asks on the chat, I don't follow the sport beyond BBC summary, so maybe this question is naive. I was expecting you to find no home advantage in yellow cards because there is no effect of the fans on the refs. Is there any way to measure if play is different without fans?
Yeah, that's a good question. And I think that gets kind of back to this chart here, is that a lot of people have this hypothesis or want to make this claim that, you know, everything home advantage wise is sort of, at least from yellow cards, is attributable to referees or fans' effect on the referee. And if we thought that was the case, what we would expect is kind of to see no home advantage, or, you know, all of these red distributions kind of centered right around 0. And while we see a decline, we see, in fact, most of them aren't necessarily 0. There's a good chance that in a lot of these leagues, the home advantage declined but didn't disappear altogether. And that sort of suggests and also prompts more questions. Well, if home advantage on outcomes like fouls, yellow cards is not entirely being driven by kind of this referee bias, you know, what are some of the other factors? I think one hypothesis could be that, like, part of the reason why there are fewer yellow cards or a yellow card advantage is it goes back to like that Messi quote about player behavior. You know, if players are feeling like these games are a lot more like training, you know, maybe they're not going into challenges as aggressively as they normally would. Maybe there are just a lot fewer of these rough collisions that lead to yellow cards in the first place. But yeah, I think it's a good question, and I think that you know, it goes to show that home advantage is, you know, it's a funny thing because it's well documented across, you know, tons and tons of sports and has been for a long time, and yet the intricacies of it are still not so well understood, and you know, it's hard to pin down exact reasons for these phenomena that we observe.
I'll just add there's a pair of papers, I'm not sure if I'm going to pronounce them right, by Leitner and Richlon, that are more thinking from like a psychological perspective, how did behavior change COVID, post COVID, and so and maybe there's tracking data that would be of assistance there, just to sort of get at what are some of the other ways that players change post COVID, that maybe isn't picked up on by goals and cards.
All right, two final questions, then we got to stop. Tommy, you're next.
Hey, could you go to the slide with your prior distributions and all of that stuff?
This one?
Yeah, so I'm wondering if you guys did a sensitivity analysis where for the random effects, TK and T prime K, if you used, either other distributions or other values for the variance, and if that changed results at all.
Yeah, we tried it with a couple different amounts of variance. I think actually these are shown as standard deviation. So the variance here is really 25. Yeah, the idea is like these are all basically very, very non-informative priors. So we didn't mess around with it too much because we didn't think it was too much use to, it wasn't like imparting any kind of expert knowledge about the problem. So I imagine if you came up with some more informative priors based on real evidence, it probably wouldn't change things too much because it already seems to converge nicely with these pretty non-informative priors.
Yeah, because with those plots, the pretty plots with the posterior distributions, it's like the red curves are so wide. And are these on the same scale as the random effects?
Well, the reason the red is so much wider goes back to
the lack of data, right?
Yeah, exactly. I mean, the sample for a lot of these post-COVID, number of games, it's like a third of a season compared to 4 2/3 seasons. So it's like less than 10% of the data, and that's probably why just the uncertainty is so much larger. I think another thing that would be really interesting to see is what happened this current season. As teams have had more time to adjust, and now I think some leagues or a lot of leagues are doing kind of partial fans, so not full attendance, but not zero fans either. We didn't really get into the nuances of combining like no fans data with very few fans data, but that would at least increase your sample size on some of these red curves.
Great, thanks.
And final question from Victor.
Hi, I'll keep this brief. I know it's at time. It's more of a comment, or I want to hear your thoughts. The discussion about yellow cards was interesting to me. I guess I'm surprised if the sentiment out there is that it's entirely or mostly driven by referee bias. I certainly, I've heard that explanation. But my sense is that, yellow cards are brought on by defensive sort of posture, attitude. I imagine, I don't have data, but I imagine that most yellow cards are sort of a defensive act. And so I could see the sort of home field, if you want to call it, as sort of partly being referee bias in pre-COVID, but then also another part of it where, certain teams go into a lot of teams in soccer, it's viewed as a draw as a good result for the away team. And so especially in leagues where there's, now I'm not looking at let's see the graph here, maybe the graph doesn't support this, I'm not sure, but like leagues that are where there's large discrepancies in the quality of the teams, the road team might be even more inclined to quote unquote play for the draw. Is that, and that could be driving some of the residual yellow card discrepancy even after the referee bias might be mitigated or gone? Is this making any sense?
Yeah, no, I mean, I think this is a good comment. We you know, early on in our work kind of looked at things like away draw rate or away win rate and some of these other like change in home advantage and seeing if there was any sort of pattern there. And I don't know how strong any of those patterns were, but it does raise an interesting question. Like, I think this German 2 Bundesliga is an interesting case study, in part because a league in the same country had a much different drop in home advantage. And one thing that's noticeable about the second league in Germany is it, I think, has like the highest or second highest draw rate of any league that we analyzed. I think in part due to there being more teams, you know, kind of larger discrepancy, like you hinted at, between the top and the bottom teams in the league. And here you see a large drop in yellow cards, but it doesn't really translate to goals. So I think, yeah, what you mentioned is interesting, and it would be really interesting to see some kind of paper that looked at tracking data and tried to compare player behavior, player actions before and after, or with, you know, with fans in the stands versus without, and you know, try to quantitatively look at this hypothesis that like maybe behaviors of players, whether they're not being as aggressive, not being as defensive minded or energetic, has any merit to it.
All right, let's thank the speakers once more. Okay, thanks everybody for attending, and a special thanks to Luke and Mike for giving a great talk. So see everybody soon.
Thank you.
Thanks all. Thanks, Mark.
Thanks, guys.